Okay, so we are on lesson 3. Today we're going to talk and learn about something called the constant of proportionality. So up in the top in this box, some points to remember that we have been talking about is that a proportional relationship has a constant ratio or a unit rate. So in order for them to be proportional, they have to have a constant ratio or a unit rate. And then a constant ratio can also be called the constant of proportionality. So that is the thing that we are learning about today, is the constant of proportionality. And it is the same thing as a unit rate, just a more formal name. And when we think about the constant of proportionality, we're going to use the variable k. So our first example says wildlife conservationists are concerned with the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. Do conservationists need to be worried? Well, before we can answer that question, let's take that information and kind of break it down. So the main thing that this question is really asking us is the unit rate of deer per square mile. Okay, so it says, what is the population density? So just how many deer? So deer per square mile. So the first thing I'm doing is setting up my label. So deer divided by our square miles. They gave me 3 different comparisons to work with. So on my paper, I'm actually going to show all 3 of them just to make sure all 3 of them have the same constant of proportionality. So I have to show all 3 of those different conservationists' countings. So the first one, it said 144 deer for 16 square miles. If I go ahead and divide that in my calculator, I'm going to get a value of 9. So that means there's 9 deer. So 117 would be the second one in a 13 square mile plot. When I go ahead and divide that, that means I get 9. And the next one, my last conservationist counted 216 deer in a 24 square mile plot. And when I divide those, I still get 9. Now I'm going to highlight all 3 of these numbers because they are all the same, which is extremely important. So the unit rate of deer per square mile is 9. That is the constant of proportionality. Now notice that's called the constant, meaning it's constantly the same. So there are 9 deer per every 1 square mile. And that's what the constant of proportionality means. So let's explain the meaning in the context of this problem. So that means what I just said. There are 9 deer for every 1 square mile. Some follow-up questions. Now that we know the constant of proportionality, we can actually answer some other questions. So it says, set up a proportion to determine how many deer there are for every 207 square miles. So before I do anything else, let me go ahead and just rewrite my label down here. So deer divided by square miles. Now, remember that a proportion, so we're going to go over to our box that says recall proportions. So remember that a proportion is where you have 2 fractions set equal to one another. They are proportional. So they're not just any random 2 things set equal. They're set equal because they have some kind of constant. In this case, it's a constant of proportionality. So we're going to set up a proportion. So I'm going to set up what I know. And what I like to say is I set up my known equal to my unknown. So I know that there are 9 deer for every 1 square mile. Notice I'm following my label, deer on the top, square miles on the bottom. I don't know how many deer there are for 207 square miles. Now to solve 2 fractions set equal to each other, remember we do something called cross multiplication. So I'm going to multiply 9 times 207 and x times 1. Well, x times 1 is just 1x or x. And 9 times 207, if you do that in your calculator, would be 1,863. So that's how many deer there would be in 207 square miles. So we just used our constant of proportionality to find how many deer for something else they gave us. We're going to try that again, but this time they want us to figure out how many square miles we would find 486 deer. So we're going to set it up the same exact way. So my known, 9 over 1, set equal to my unknown. This time I know that there are 486 deer, but I don't know in how many square miles. Now, this is why it's very important to not just show your work and go through each step, because when we cross multiply here, we're not just multiplying 9 times 486, because what we get is 9 times x equals 486, and this is a one-step equation. So we have to actually solve this for x through one step. Remember, I'm going to take 9. I have to isolate my variable. So my variable here is x. I need it all by itself. So I have to move this 9 to the opposite side. Well, to go to the opposite side, I have to use the opposite equation. So opposite of multiplication is division. So I'm going to take 9 divided by 9. Well, that's just 1. But whatever I do to one side, I have to do to the other. So x equals 486 divided by 9, which is 54. Okay, example 2. It says Isaac makes breakfast on Monday and uses 1/3 of a cup of milk for his 2.5 pounds of cereal. And on Tuesday he has the same. So this is going to be a little tricky just because it moved onto another paper. So on Monday he uses 1/3 of a cup of milk for 2.5 pounds of cereal. So that's going to be something we need to know. So I'm just going to move that. So 1/3 of cup of milk, 2.5 pounds of cereal. 1/3 cup of milk to 2.5 pounds of cereal, just so that we don't have to keep going back and forth. Okay, so they're asking us, does Isaac use a proportional amount of milk per pound of cereal for his breakfast? How do you know? Okay, well, before we can figure out if this is proportional, we first have to find out the unit rates for both Monday and Tuesday. So let's start with Monday. So I'm just going to split my paper. So this is Monday. Oops, not mom. Monday and Tuesday. Okay, so before I begin, I'm going to go ahead and set up my label. So it says milk per pounds. Milk per pounds. So milk divided by pounds. On Monday, we used 1/3 a cup of milk and 2.5 pounds of cereal. You can go ahead and put that in our calculator. We're going to get either 0.133333, so 0.13 repeating, or 2/15, whichever you would like to write. I'm going to put my decimal 1.3 repeating, or sorry, 0.13 repeating. And on Tuesday, I have that he uses 2/3 a cup of milk for 3 pounds of cereal. When I divide this, I get 0.2 repeating. So when I take a look at the comparison between these two ratios, what happens is they are not the same. So since those two values are not the same, this is not proportional. So no, because it asks us how we know, no, because the unit rates are not the same. And when you give your explanation, you have to include the reasoning, the fact that the unit rates are not the same. Then it says, is there a way to determine how much milk Isaac would need for 4 pounds of cereal? Well, if we compare this to what we did for the deer had a constant of proportionality. So there was a way for us to set this up. But because there isn't a constant of proportionality and these two values are not proportional, we cannot figure out how much milk he would need. So we're going to say no, because he does not have a constant of proportionality. In other words, that just means that as he increases the amount of cereal he uses or the amount of milk he uses, there is no constant rate that the milk to cereal ratio is changing. Okay? So to sum this up, it says, what is another name for the constant that relates to the measures of two quantities? This is our unit rate. And today we also learned that that unit rate can also be called the constant of proportionality. Remember, our constant of proportionality is denoted by the variable k. It says, how is this related to the unit rate? Well, they are exactly the same. They are no different. All right, good luck on your homework.